Okay, this list of numbers is the number of daily grades given in different classes in a 9 weeks grading period. So we have this set of data. So the first thing we want to do before we analyze all these data points is we want to put them in order from least to greatest. So I'm going to start with the smallest value, which is 8, and list them out from least to greatest. Okay, so now that I have them listed out from least to greatest, my smallest number, the lowest value in that list, is going to be our minimum. So our minimum is 8. And then the largest value, 30, is our maximum. So our daily grades range from 8 per 9 weeks to 30 per 9 weeks. So finding the difference between the minimum and the maximum is called finding the range. So if you take the largest value, the maximum 30, and you subtract the smallest value, 8, that gives us our range. So the range of daily grades is 22. That's the difference between the least amount of daily grades and the largest amount of daily grades. So from middle school or maybe even elementary school, the words mean, median, and mode might mean something to you. So the mean is the average. So the way that you find the mean is you add up all of your values and then you divide by the number of data points. So we're going to add up all of these number of daily grades and then divide by the number of data points, which in this case is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our sum of all of those number of daily grades is 137. I'm going to divide it by 9. And so that mean, the average number of daily grades given per 9 weeks is 15.2. So this is interesting. First off, 15.2 is not one of the numbers in our data set. It's not listed here. So the mean does not have to be one of the numbers on your list. The second thing, it's not actually possible for a teacher to assign 15.2 daily grades. They can assign 15 or they can assign 16. So this is kind of like when you hear statistics and data about like the average family has 2.5 kids. Like that doesn't make any sense. You can't have 2.5 kids. But that's okay. It's just the average. It's not actually doesn't actually have to be an actual piece of data. Okay, so mean is the average. The mode is the most frequently appearing piece of data. So if all of my number of daily grades just appeared once, then I wouldn't have a mode. But I noticed right here, I have 2 teachers that gave 15 daily grades. So my mode is 15 because that number appears the most number of times on our list. Okay, and then the last one is the median. The median is the middle of the data set. So if I have 9 pieces of data, if I have 9 data points, the median is going to be the halfway mark. Halfway, I'm going to count like from one end to the other. So my first and my last, then I'm going to scooch in one, first and last, first and last, and then my middle of my data set is right here at 15. So that's my median. So if you notice, there are 4 pieces of data to the left of our median, and there's 4 pieces of data to the right of our median. It's right smack dab in the middle of that list. And so half of the data is less than the median, and half of the data is greater than the median. So 50% is below the median and 50% is above the median. So now that we have identified our median, we've identified our middle of our data set, we're not only going to break it into the bottom half and the top half, we're going to break it into quarters, into quartiles. So we want to find the median of the bottom 50%, because that will tell us where the 25% tile marker is. So again, we're going to cut our data set not just into halves, but now into quarters, into quartiles. So if I'm looking at 15, which is my median, there's 4 pieces of data less than 15 in the bottom half. So if I'm going to cut that set of 4 pieces of data in half, then I'll have 2 pieces of data in the bottom quarter and then 2 pieces of data in the second quarter. So this halfway mark between the bottom 50% is going to be in between 9 and 10 at 9.5. So that is called Q1. So it's marking the cutoff point for that first quarter, that bottom 25%. Okay, then I'm going to do the same thing for the top half. So if there's 4 pieces of data that are greater than our median, and I want to cut that top 50% into 2 halves, I'm going to have 2 pieces of data that are in the bottom half and 2 pieces of data that are in the top half. So that cutoff point is going to be halfway between 17 and 21, which is 19. That's called Q3. So if this first marker is Q1 and this marker over here is Q3, that median is also called Q2. Halfway in between Q1 and Q3 would be Q2. So if you notice, we've taken this set of data and we've cut it into 4 sections. There's 2 pieces of data in the first quartile in the first section. There's 2 pieces of data in the second quarter in the second section. There's 2 pieces of data in the third one, and there's 2 pieces of data in the fourth one. So another way to think about this is 25% of teachers gave in between 8 and 9.5 daily grades. 25% of the teachers gave between 9.5 and 15 daily grades. 25% of the teachers gave between 15 and 19 daily grades. And then 25% of the teachers gave between 19 and 30 daily grades. So it's giving you those different sections. It's splitting the data into 4 equal pieces so you can kind of see how it's spread out. Now we can take that data and we can make it visual on a box plot. So I'm going to have a number line, and I've put my minimum at the far left and my maximum at the far right, and then my units are consistent, so each tick mark is just worth 1 daily grade. So here's my median. So if you notice, it doesn't appear to be exactly halfway in the middle of the number line, because if you notice, this bottom half, the spread is from 8 to 15. That's 7 daily grades. But from 15 to 30, that's 15 daily grades. So the difference between the minimum and the median is a lot smaller than the difference between the median and the maximum. Hence, it gets represented on the box plot like that. So we're going to put our a dash at our minimum. We're going to put a dash at Q1. So 9.5 is right there, halfway between 9 and 10. We're going to put a dash at the median, which is at 15. We're going to put a dash at Q3, which is right here, 19. And then we're going to put a dash at the maximum, which is 30. Okay, then I'm going to draw a line connecting Q1, or connecting the minimum in Q1. Then I'm going to draw a box connecting Q1 and Q2, my median. I'm going to draw another box connecting Q2, Q3, and then I'm going to draw a line connecting Q3, the maximum. So 8 is my minimum. This number right here represents Q1. This is Q2, which is our median. This is Q3. And then here's our maximum. So this is called a box and whiskers box plot, because you can think of these as our boxes and these as like the whiskers that come off the sides. And it just helps us visualize the spread of our data, or like how are the quarters kind of clumped together. So if you notice, there's not a ton of spread in that first quartile. It only goes from 8 to 9.5. So that line is pretty short because that's only 1.5. That's the spread is only 1.5. Versus the spread between Q3 and the maximum is between 19 and 30. That's 11. So that spread is a lot larger than over here. So what this box plot is showing us is 25% of the data points, so 25% of teachers assigned between 8 and 9.5 daily grades. 25% of teachers assigned between 9.5 and 15 daily grades. 25% of teachers assigned between 15 and 19 daily grades, and 25% of teachers assigned between 19 and 30 daily grades. The other thing is this idea called the interquartile range, IQR. The interquartile range is the range, instead of between the maximum and the minimum, which is what we did for just the regular old range, the interquartile range is the range between Q3 and Q1. So it's essentially like, what's the spread that's in the box? So what's the range of what goes in the boxes, not in the whiskers? So the difference between 19 and 9.5. So the IQR is 9.5. So that means